Hey, it's Dr. J. Trying something new today. Today we're going to do more calculating in other bases. In particular, we're going to focus on the fundamental operations of addition, subtraction, and multiplication today. Division is a whole other story. So in this particular example, we have base 2. The subscripts, again, are just to indicate the base. It's also to remind us that when we are adding, keep this in mind, 1 plus 1 is 2, but 2 looks like a 10. So keep that in mind. Everything else about binary addition is just like normal addition or regular addition. You would have 1 plus 0 is 1, and 0 plus 1 is still 1, and of course 0 plus 0 is still 0. So we're going to add vertically in columns. Go ahead. 0 plus 1 is 1. Okay. 1 plus 1 is 2, but remember what 2 looks like. 2 is a 0, and then you carry a 1. All right, so it's like carrying a 10, and you would do an ordinary addition, but we're carrying a 2. So now you have 1 plus 1 plus 0. You're adding all these up. That's again 2, but you can't write 2. You have to write 10. Okay. 1 plus 1 is 2. 2 plus 1 is 3. Yeah, do you remember what 3 looks like in binary? 3 looks like an 11 in binary. So 1 plus 1 plus 1 is 3, but it looks like an 11. So 1, 1, you carry another 1. 1 plus 0 plus 1 is another 2. 2 looks like a 10. Carry a 1. 1 plus 1 is, again, 2, but it looks like a 10. And so this is your result, base 2. Sound good? All right. This is how a calculator or a computer would calculate addition. On the screen, you see the Hindu-Arabic numerals, but inside the machine, it's adding ones and zeros. Example 2, subtraction. Base 2. So when we're subtracting numbers in base 2, we got to keep in mind that instead of borrowing a 10, you borrow 2. But it looks like a 10. So here we go. 0 minus 1. Well, I cannot subtract 1 from nothing. So I'm going to borrow from this, which really means 10, but really means 2. It looks like a 10. It really means 2. And so this is now going to become a 2. It looks like a 10, but it's a 2. So 2 minus 1 is 1. All right. 0 minus 0, that's 0. 1 minus 1, that's 0. 1 minus 1, that's also 0. And now when you get to the end, you can just subtract. Remember, this really means 2. 2 minus 1 is 1. And so this is your answer, base 2. Okay. Example 3. Come on, focus. Focus. Multiplication in base 2. 1, 0, 1, 1, 0 multiplied by 1, 0, 0, 1 in base 2. Nice thing about multiplication is the rules are very simple. 0 times 0 is still 0. 1 times 0 is 0. 0 times 1 is 0. 1 times 1 is 1. So you don't have to worry too much about the rules of multiplication. They're exactly the same rules that you would ordinarily know from basic math. What you really need to worry about is the next step after you multiply, remember, is addition. So we have to keep that in mind. So we're just going to multiply as normal. You really don't need these bases. Oftentimes we omit them so that they don't get in the way. Once it's clear that it's base 2, you don't really need these bases anymore. Okay, they kind of get in the way. You might accidentally multiply by 2 or something. So 1 times 0, that's 0. 1 times 1, that's 1. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. Okay. Put a placeholder and do it again. 0 times all of these numbers are all going to become zeros. 0 times 0, 0 times 1, 0 times 1, 0 times 0, 0 times 1. You could probably just skip that row. Since this is the first time I've done this for you guys, I'm not going to skip that step. Then you're going to put 2 placeholders. And again, 0 times 0, 0 times 1, 0 times 1, 0 times 0, 0 times 1. So these 2 rows, if you remember that they are insignificant, you just have to put 3 placeholders to get to your last digit here. You could have just omitted these. Just like you would do in elementary school. If you had a whole row or 2 rows of zeros, you would just omit them. You do need to remember that now you have 3 placeholders. All right, there's this sort of triangle here of placeholders. All right, so we get to the next, the last number, which is a 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. So the multiplication process is relatively simple. It's the adding you need to worry about. So now you're going to add down. 0 plus 0 plus 0 plus 0, that's 0. 1 plus 0 plus 0 plus 0, that's 1. 1 plus 0 plus 0 plus 0, that's also 1. 0, 0, 0, 0, that's 0. Now here's where it gets tricky. Remember, 1 plus 1 is 2, but 2 looks like 10. So you have 1 plus 1 is 10, or 2, but it looks like 10. So you carry the 1. 1 plus 1 is another 2, again, but it looks like a 10. 1 plus 0 is 1, and then just bring down the last digit if there's nothing to add. And this is your product. This is your answer, base 2. Okay, so we've added, subtracted, and multiplied in base 2. I'm not going to do every base. I'm going to do the same bases that I did in the previous part of these lectures. So let's move on to base 3. Let's go to addition. Base 3. So we might need a little reminder of the rules of base 3. 1 plus 1 is 2. 1 plus 2 is 3, but it looks like a 10. So hopefully you've gotten the hang of that. When you are in a particular base, the number that used to be what we used to refer to as 10 now equals whatever that base is. So the symbol that looks like 10, or the symbols that look like 10, is actually a 3. Everything else is normal. Yeah, everything else is normal. 1 plus 0 is 1. 2 plus 0 is 2, so on and so forth. 0 plus 0 is 0. None of the other rules change. Only these special base rules that we have to keep in mind here. So again, we're in base 3 here. Once it's clear what the base is, I actually like to cross off the base because it just gets in the way. 0 plus 1 is 1. Right? 2 plus 1. 2 plus 1 is 3, but it looks like 10. Oh, also you might want to know 2 plus 2 is 4, but 4 looks like 11. So I've got 1 plus 1 is 2, plus 2 is 4, but 4 looks like 11. Okay. And 5 looks like 12. 5 looks like 12. So 1 plus 2 plus 2, that's 5, but you can't write the number 5. This is the number 5 right here, which would be, I guess, 3 plus 2 is 5. Yeah, 3 looks like 10. 2 still looks like 2. So 3 plus 2 is 12. So this is your answer, base 3. After I teach you all this arithmetic, then we'll actually talk a little bit about what it's used for. I'm the kind of guy that doesn't really care what it's used for while I'm learning it. Just learn it. Get good at it. And once you get good at it, then you get to learn what it's used for. It's what I call the Karate Kid method. I'm not going to teach you karate today. Example 5. You know exactly what I'm going to do next. Subtract. Base 3. So I have a base 3 number minus another base 3 number. All right, I'm subtracting. Again, once I've made it clear what the base is, I like to just cross off the base because it's not necessary once it's clear. That's what I do because I don't want to accidentally go 3 plus 3 or something like that. I've seen people do that. Remember, my philosophy I always teach in class is whatever can go wrong will go wrong. So make sure you do whatever it takes. All right, we're subtracting. All right, 0 minus 1. Well, we can't do 0 minus 1. So when we're subtracting, what are we borrowing? We're borrowing 3. But 3 looks like a 10. So we're going to borrow from this 2 here. So this now looks like a 10, but this is actually 3. Even though it looks like 10. So this is 3 minus 1, which is 2. Okay, and we borrowed 1 3. So now there were 2 3s. Now there's only 1 3 left. Okay, so 1 minus 0 is 1. Now again, that looks like 1, but it actually means 3. 2 minus 1. 2 minus 1 is just 1. And then 2 minus 2 is 0. Usually omit the leading 0 and just write your answer. It looks like 112, but it's not. At any time, if you're curious what your answer means, you can figure it out. The 2 actually means 2. The 1 means 3 times 1. And the other one means 3 squared times 1. So 9 times 1. So what this actually means is 9 plus 3 plus 2. So this actually means 14. Now don't write 14. It's just telling you, if you're curious, what does this number mean? It does not mean 112. It actually means 14. Let's multiply base 3. Okay. So we're going to multiply base 3. The multiplication rules are relatively simple. The main thing you want to keep in mind, most of the rules are going to be the same. 1 times 2 is 2. 1 times 1 is 1. The main thing you want to keep in mind is 2 times 2 is 4. But what does 4 look like? 4 looks like an 11. Remember, because 3 looks like a 10. So keep these in mind. When you add 2 plus 1, you're going to get 3, but it looks like a 10. And when you multiply 2 times 2, you're going to get something that looks like 11, but actually means 4. I'm going to cross off these bases now because they're just getting in my way. 1 times 2, 2. 1 times 1, 1. 1 times 2, 2. Put a placeholder. 2 times 2. 2 times 2 is 4, but it looks like an 11. So you're going to put a 1, and you're going to carry a 1. 2 times 2 is 4, plus 1 is 5. Well, if 4 looks like 11, well, then 5 looks like 11 plus 1, which looks like 12. Base 3. So this is what 5 looks like. So 2 times 2 is 4, plus 1 is 5. 5 looks like 12. Okay. And now you're going to add these together. The second step of multiplying is adding. 2 plus 0 is 2. 1 plus 1 is 2. 2 plus 2 is 4, but 4 looks like 11. So that's your 11 right there. And then 1 plus 1 is 2. So this is your product in base 3. Okay. Just a couple more bases to go. Let's do base 5. Focus. All right, hopefully that's good enough. So we're going to add in base 5. Let's make that a 3. Okay, adding in base 5. Let's see if we can get a better focus on this. There we go. So adding in base 5. A little subscript here for base 5. Keep in mind in base 5, 5 looks like 10. Okay. Now I can cross off these bases. I don't need them anymore. 1 plus 2 is 3. 2 plus 3 is 5, but 5 looks like 10. Carry the 1. And then 1 plus 3 plus 1 is another 5, which looks like 10. So it looks like 1003 base 5, but it's not. Again, if you're curious what this means, write it out. It would be 1 times 5 to the third plus 0 times 5 squared plus, so each term comes down, plus another 0 times 5, and then plus 3. The last digit really means what it says. So this would be 125 plus 3 plus a pair of zeros here. So it would be 128. That's what this answer actually means, 128. Again, I don't want 128 as the answer. You can think that in your mind. This is what I want you to write, 1003. Subtracting in base 5. All right, subtracting in base 5. Again, keep in mind when you're subtracting the concept of borrowing. You're borrowing 5s, which looks like a 10. All right. And again, I'm going to cross off my base so it doesn't get in my way. All right. So I've got 1 minus 2. I'm already stuck. I can't do it. So I'm going to borrow from the neighbor. All right. So I'm borrowing a 5, but it's going to look like 11. 11 is actually 6. I like to write the word instead of the number. So this that looks like 11 actually means 6. So this means 6 minus 2. 6 minus 2 is 4. Remember, you can't have a symbol here for 6. The symbol for 6 is 1, 1 because we're in base 5. 3 minus 3, that's 0. All right, 2 minus 4. I can't do 2 minus 4, so I'm going to borrow from the 3. That's going to look like a 12, but it's actually a 7. Just look at the pattern. If the number that looks like 10 is 5, well, then the number that looks like 11 is 6. And then the number that looks like 12 is 7. So this is 7. 7 minus 4 is 3. And then the last digit is 2. You could think of this as 2 minus nothing, which comes out to be 2. And that's your number, base 5. Probably guess what we're going to do next. Multiplication, base 5. We're really cooking now. $41 times 32. Again, base 5. So keep in mind when you're multiplying, something that looks like 10 is actually a 5. If it looks like an 11, it's actually a 6. If it looks like a 12, it's actually a 7. If it looks like a 13, it's actually an 8. If it looks like a 14, it's actually a 9. And 10 looks like 20. All right, so just keep that in mind when you're doing your multiplication. If you happen to get any of these larger numbers, if you get something smaller than 5, don't worry about it. It's just whatever it is. But it's only when you get larger than the base, greater than or equal to the base, that you have this adjusting the symbols to be according to the base. So again, I like to scratch off the base so I don't accidentally go 5 times 5. 2 times 1 is 2. 2 times 4. There we go. That's 8. But 8 looks like 13. Again, I'm omitting the subscripts while I'm doing my calculation because the subscripts really just get in the way. Put a placeholder. 3 times 1 is 3. 3 times 4 is 12. What does 12 look like? Well, if 10 looks like 20, then 11 looks like 21, and 12 looks like 22. So 3 times 1 is 3, 3 times 4 is 12, but 12 looks like 22. And then I add these up. 2 plus 0, 2. 3 plus 3 is 6, but 6 looks like 11. Carry the 1. So I've got 1 plus 1 plus 2. That's just 4. Remember, if you're less than the base, it's just whatever it is. And then 2 just comes down and has nothing to add with. And so that is your product in base 5. Okay, just a few more examples. I hope you like this new format. I still have a little adjusting to do with the color and the light and stuff, but it's nice to see you. Okay, so example 10. Add in base 8. If you're counting, we have 3 more examples. We're going to add, subtract, and multiply in base 8. Again, these are base 8 numbers. There's typically a little subscript here that tells me what the base is. As soon as it's clear, you can wipe that off. All right. Keep in mind when you're in base 8, 8 looks like 10. 9 looks like 11. 10 looks like 12. 11 looks like 13. You can only use symbols up to 7, one less than the base. 12 looks like 14. 13 looks like 15. 14 looks like 16. 15 looks like 17. And so 16 looks like 20. You see the pattern? Once you get to the 7, you can't use the symbol 8. In fact, I like to cross the symbol off because technically that 8 is really not there. It's really just a visual assistant while you're learning the process. In practice, we don't use those subscripts because that symbol is not really there. So 4 plus 3 is 7. That's okay. You can use the symbol 7. 6 plus 7. 6 plus 7 is 13. But you can't use the symbol 13. You got to use the base 8 symbol for 13, which is 5, 1. And 1 plus 2 is 3. Remember, as long as the digits are less than 7, they mean what they say they mean. So this is base 8. Again, if you just can't stand the curiosity, you want to know what that means. This means 3 times 8 squared plus 5 times 8 plus 7. So this would be 3 times 64 plus 40 plus 7, which would be 192 plus 40 plus 7. So what would that be? 239. If I did that right. 192 plus 40 is, what's that? 232 plus 7 is 239. It looks like 357, but it actually means 239. Subtract base 8. Subtracting in base 8. Again, we could put a little subscript here to indicate the base. You're probably getting sick of me saying that all the time. But the subscript is going to be there, and you should probably make a note of it and then immediately get rid of it because the subscript causes more problems than it does good. So subtracting in base 8. Again, subtracting is borrowing, right? You're going to use the borrowing. But you're not really borrowing 10, you're borrowing 8s. But 8 looks like 10. So keep that in mind when you're doing your subtraction. You ever had this happen before? When you go to borrow and your neighbor doesn't have anything to borrow from, you have to borrow from your neighbor's neighbor. So you're going to borrow from the 5. Okay. Now be careful. This looks like a 10, but it actually means 8. Yeah? So when you borrow from it, it doesn't become a 9, it becomes a 7. Because if you have an 8 and you borrow 1 from an 8, now you've got 7. Capiche? Okay. So 13 minus 5. 13 minus 5. 13 minus 5 is 8. Yeah. So you put a 0. And you carry the 1. Now again, this looks like 17, but it's not. It's actually 8. It's 7 plus 1. So this is actually 8. So 7 plus 1 is 8. 8 minus 1 goes back to being 7. All right, let's try that again. 4 minus 7. We cannot subtract 7 from 4. So we're going to borrow 8. But it looks like a 10. So this number looks like 14, but it's actually 12. Yeah, because this is like 8. This 10 means 8 plus 4. So the number that looks like 14 is actually 12. So in your mind, you're thinking 12 minus 7. 12 minus 7 is 5. And then finally, 5 minus 4, that's easy. 5 minus 4 is just 1. So there's your value, base 8. That one's pretty messy. I admit that one was pretty messy. It got kind of hairy right about here. All right, I'm getting tired, and you're probably getting sick of this as well. So we'll do one more example, multiplication, base 8, and then we'll be done with this lesson. Multiply in base 8.
How about the egg and sausage sandwich? Jake, you good?
So multiplying base 8. I'll keep the numbers relatively small because we got to keep track of what's going on here. So remember, 8 looks like 10. I had that list earlier. You might want to just keep that. 9 looks like 11. 10 looks like 12. 11 looks like 13. 12 looks like 14. 13 looks like 15. Etc., etc. All right, we'll keep going and we'll grab another one if we need one. We're probably going to need one right away, aren't we? 13, 14. 14 looks like 16. 15 looks like 17. And 16 looks like 20. All right, so again, I like to cross off the base. Just get it out of my way. 5 times 3, 3 times 5, that's 15. So it looks like a 17. So 7 and then carry the 1. Okay, 3 times 2 is 6. 6 plus 1 is 7. Put a placeholder. 1 times 5 is 5. 1 times 2 is 2. I like to cross off that so I don't double count it. Now add these up. 7 plus 0 is 7. 7 plus 5 is 12. But remember, 12, come over here. 12's not really 12. 12 looks like 14. Carry the 1. 1 plus 2 is 3. So this is your product in base 8. It looks like 347, but it's not. It's much larger than that. Okay. It's actually not much different, but I'll leave that to you to calculate if you want. Okay, Dr. Jordan signing off.